In this video we're going to be looking at compound inequalities, and you may be familiar with compound words or compound sentences, and that's where we take two or more parts and put them together. Here we're going to be looking at two or three inequalities that we've put together and how they're related to their solutions and how we find the numbers that work for those two inequalities when they're combined. The first thing we need to talk about are the and or. So these are the two types of inequalities that we're going to have, and they're going to be two inequalities that are linked using either the word and or the word or. When we talk about and, this is what we call the intersection of two inequalities. So you can see here in red we have our solutions marked off. This is different than the graphs that we've looked at in the past because you'll notice it's contained on both sides. We have an open circle here and a closed circle. There's no arrows, there's nothing going off in either direction infinitely. We just have this distinct set right here on the number line. When we think about an and inequality, it's really the intersection or the overlap of two separate inequalities. So if I look at this first one, I have an open circle on the left on -4, and I have numbers that are greater than -4. So I can assume that this is going to be the inequality x is greater than -4. But we also have another inequality that we're dealing with. We have a closed circle on 2 going to the left. So this is everything that's less than or equal to 2. So if we put those two inequalities together and we look at their overlap, that's going to be the inequality that we have here. The part that's the same for both inequalities. And the way that we would write this inequality, we start with our number on the left, which is -4. We have our variable or our solution, which is everything in the middle, and then we have our number all the way on the right, which is 2. Since we have that closed circle on 2, we have x is less than or equal to 2, and then we have the open circle at -4, so x is greater than -4. If we wanted to put this in set notation, we would just add our definition in our brackets like this. And this tells me that my solution set is the values of x, such that x is between -4 and +2. I have the or equal to here on the right, so I'm including +2, but I'm leaving out -4. This is the intersection or the overlap of the inequalities in blue and green. The second inequality that we'll look at for compound is the or inequality. And this is where we're basically taking the union or the combination of two different inequalities. So my first inequality that I have here, I have a closed circle on 6. So I have x and 6. I have everything greater than that off to the right. So we have x is greater than or equal to 6. And then here we have everything that is less than or equal to -8. To get the union of those two inequalities, we just combine them together on the same number line. So this problem might be given to you as x is less than or equal to -8 or x is greater than or equal to 6. When we write this in set notation, we still take the values of x such that x is less than or equal to -8. We put this union symbol in the middle to show that we're linking the two together, and then we write in our second inequality. So this is where we basically take the two inequalities and put them on the same number line. We're looking at the combination. And is always going to be more strict than or. It's going to be usually a smaller solution set. There are going to be some values that we leave out, or we don't leave anything out. We take everything from both inequalities and put them together. When we solve these, we basically break them up, solve each inequality separately, and then put them back together at the end. So if we look at the inequality on the left here, I have the and in the middle, which shows me that at the end we're going to be looking for the intersection of whatever we get on the left and whatever we get on the right hand side. Go ahead, pause the video, see if you can solve the left and solve the right, and then we'll come back together and put them together for the and compound. Alright, so here we end up with x is less than 2 and x is greater than or equal to -3. If I want to write this in set notation, I take my smaller value, -3, we take our x and our larger value, 2. Then we have x is strictly less than 2 and x is greater than or equal to -3. We have our x such that with our definition in the front. Now we can go ahead and plot this on the number line. When I'm doing this, instead of putting 0, our number and its opposite, now we just have two numbers, so I could put -3 where it goes in the number line. I can put 2 where it goes in the number line, and we fill in based on our inequality. So we have x is greater than or equal to -3, so we fill in that circle. Then we have x is less than 2, so we have an open circle. Then we want all the values in the middle, so we connect the dots. Now we need to think about our interval. Instead of going off to negative infinity or off to positive infinity, our solutions live right between -3 and 2. So those are the two numbers that go in my interval. Then I look at the graph or at the inequality to see whether I use parentheses or brackets. So at -3 we have a closed circle, which means we need a bracket, and then at +2 we have an open circle, which means that we get a parenthesis. If we look at the second inequality, we'll see that this one is written kind of as a triple. Whenever I see this, I'm going to split it into two separate inequalities to solve. So the first inequality I'm going to solve is the one I've circled in red. -7x minus 8 is less than -10x plus 1. Then I'm also going to solve this inequality. -10x plus 1 is less than 9x plus 1. Go ahead and pause the video, see if you can solve each of those separate inequalities. If we solve the inequality in red, we get that x is less than 3. If we solve the inequality in purple, we get that x is greater than 0. So we need all of the numbers that are less than 3 while at the same time being greater than 0. If we look at each of these on the number line, we can figure out what our final graph should look like. So I've got 3, I've got 0. I want everything that's less than 3, so we've got this, and then everything that's also greater than 0. Remember that and is the intersection or the overlap of these two graphs. So that's going to be everything in the middle here from 0 to 3. So if I take out everything I don't need, we can see what our final graph will look like. I don't need anything that's less than 0, and I don't need anything that's greater than 3. So if we put this all together and neaten it up, we will see that we have open circles on both 0 and 3, since our inequalities were strictly less than and strictly greater than, and a line connecting them in the middle. Our final compound inequality will be the values of x such that x is greater than 0 and less than 3. Whenever we write these inequalities, we'll always have the smaller number on the left and the larger number on the right, just like when writing intervals. Our inequality symbols will also always open up towards the right. We'll never flip them back around to the left. If I look at my interval, my values run from 0 to 3, and I have 2 open circles, so that means I have 2 parentheses. Now we're going to look at what happens for our special cases with compound inequalities. Take a minute, pause the video, and see if you can figure out what to do with the inequality on the left. When we solve the left part of the inequality, the one in green, we get that k is greater than or equal to 0. When we solve the right-hand side, we get that k is greater than or equal to 3. So this is unusual because usually with the and inequality, we have something where the variable is less than a number and something where the variable is greater. But here we have two inequalities facing the same way. If we look at our graph on the number line, you'll see that instead of having two arrows going in opposite directions, both of our graphs head off towards the right. When we talk about the intersection or the overlap, our overlap starts at 3, and our overlap continues off towards the right. So, if we're talking about the intersection, everything that's greater than 3 is also going to be greater than or equal to 0. So our final simplified solution is just going to be the values of k such that k is greater than or equal to 3. If we just take the overlap part of our graph, then all we need to worry about is an open or a closed circle on 3 and an arrow heading off to the right to take all of those values that are greater than or equal to 3. If we go to put that in set notation, this looks like the ones before we did compound inequalities. We have the values of k such that k is greater than or equal to 3. If we think about our interval, we have negative infinity on the left, positive infinity on the right. We're going from 3 off to infinity. Since it's a closed circle on 3, we have the bracket, and then infinity gets the parenthesis. Pause the video and take a stab at the one on the right. Alright, so we start off by solving the inequality on the left in red, and we get x is less than or equal to negative 12. So for our graph, we have a closed circle at negative 12. We want everything less than that off to the left. And we solve the inequality on the right in blue. We get x is greater than negative 10. So we have the open circle at negative 10, and we take everything off to the right. Now, remember, because this is an and inequality, we want the overlap, or anything that is on both graphs. However, there is no overlap. Nothing in the red overlaps with the solution set in the blue. This means that there are no values that satisfy this inequality. No matter what number I plug in there, I'm going to get a statement that's not true. This means that we have no solution. There's nothing that works for both of these inequalities at the same time. My graph for no solution, like we talked about before, is just going to be an empty graph. There are no values that we include on there. You can have negative 12 and negative 10 for reference, that's fine, but you don't need them. But there shouldn't be any dots or any lines drawn on top of the graph. There's nothing that we can include in our solution set. And then remember, for set notation, we just have the empty brackets, and there's no interval when we don't have a solution. Okay, now we're going to look at the OR compound inequalities. This is where we solve each inequality. We take the two solution sets, and now we just put them together. We take numbers that work for the first, numbers that work for the second, dump them all together, and that's our solution set. So go ahead, pause the video, and see if you can solve the inequality on the left on both sides of the OR. Alright, the inequality on the left in blue gives us the values of k greater than or equal to 9. The value of the inequality on the right gives us the values of k less than or equal to 2. Because this is an OR a union, we take everything that works for the red inequality, put it together with everything that works for the blue inequality, and call it our solution set. And for this graph, this is all that I need. I have everything that works for the one combined with everything that works for the other. In set notation, we're still going to take the values of k such that we start on the left, so k is less than or equal to 2, union k is greater than or equal to 9. We take the two inequalities, we put them together. Now for the interval notation, this is where things get a little more interesting. So we have negative infinity on the left, positive infinity on the right. Because there are two pieces to my graph, I'm going to actually have two intervals, one for the piece on the left and one for the piece on the right. Then we link them together with the union symbol like we do in the set notation. So my interval on the left runs from negative infinity to positive 2. We have a closed circle, so we get the bracket on 2 and a parenthesis on negative infinity. We're going to take the union of that interval with the one on the left. We went from 9 to positive infinity. 9 has a closed circle, so it gets the bracket. Infinity has a parenthesis because it always does. And that would be our final interval. Go ahead and pause the video and see if you can do the one on the right. Alright, so we solved the inequality on the left. We get x is less than or equal to negative 2, which means a closed circle at negative 2, heading down to the left to negative infinity. Then if we look on the right hand side, we get x is greater than 1, which means we have the open circle at 1, and then taking everything greater than that to the right to positive infinity. So in set notation, again, we're just going to take the two inequalities and throw them together. So we have the values of x such that x is less than or equal to negative 2. Take the union of that with our other inequality, x is greater than 1. Now for the intervals, we write the interval of the first part and link it with the interval of the second part. So our first interval runs from negative infinity to negative 2. We have a parenthesis on negative infinity and a bracket on negative 2. Our second interval runs from 1 to positive infinity, and those are both parentheses. And then we have the union link in the middle. We're going to take a look at two special cases here. Now, knowing what you know about the special cases from the AND inequality, I want you to pause the video and see if you can figure out the solution to the inequality on the left. Alright, this one's interesting. If we solve the inequality on the left, we get down to 4 is less than negative 6. This is a contradiction. So our inequality on the left doesn't have a solution. No solution there. If we solve the inequality on the right-hand side, we do get a solution set. We get the x is less than negative 18. Now, remember that this is the union, so we're taking all the solutions from the left and combining them with the solutions on the right. Except there are no solutions to add in here. So our solution set is just going to be this x is less than negative 18. So in set notation, we have the values of x such that x is less than negative 18. And in our interval notation, we're heading down to negative infinity here. So we have negative infinity to negative 18, and we get 2 parentheses there. Now, say we had the intersection of no solution and x is less than negative 18. As soon as I get no solution, there's no overlap there. So that would not work. So if we solved an AND inequality and we ended up with these two options, that would be no solution. But here, because it's OR, we just take the one that does have an answer, and that represents the entirety of our solution set. Go ahead and pause the video and try the other one. Alright, so when we solve the inequality on the left, we get n is greater than 3. And when we solve the inequality on the right-hand side, we get n is less than or equal to 7. So now I'm going to take these two inequalities and I'm going to combine them together with or the union. Okay. Okay. Now, we want to think about the best, most simplified way to represent our answer. If I look at my blue inequality, x is greater than 3, I have all these values towards the left-hand side that aren't included in that. But they are included on the red inequality because they're covered by n is less than or equal to 7. Likewise, if I look at my red inequality, I have all these values to the right of 7 that aren't covered. But they are part of the solution set for n is greater than 3. If I test any number on the number line, it will work for either the blue inequality or the red inequality. This means that every single value on the number line is part of my solution set. So this is actually all real numbers. Anytime we have an OR inequality and they have this overlap in the middle going off in opposite directions, that means we're going to cover every single value in the real number system. So my final graph is going to be that all real numbers graph. Again, you can leave 3 and 7 on there for reference, or you can just use the 0. But my final graph is going to be that all real numbers graph. In set notation, we want the values of n such that n belongs to the real number system, and my interval runs with my graph from negative infinity to positive infinity. And this would be your final answer. You don't want to leave that non-simplified graph. You don't want to leave a non-simplified inequality. You want to take it all the way down to its simplest, most accurate form, which is all real numbers. Alright. The last thing we're going to look at is kind of going backwards from intervals to compound inequalities. So I want you to pause the video and see if you can do the first 3 inequalities on your own. Take a look and see how you did. The first interval tells us that we have all the values from negative 3 to positive 8. We have a parenthesis, which means we have an open circle, and then a bracket, which means we have a closed circle. So we take everything in between. Same thing for the next one. We have everything between 5 and 8, except now we have 2 brackets, which means we have 2 closed circles. For the next one, we have 2 different intervals, which tells me that my graph is going to have 2 distinct pieces. The first runs from negative infinity to 4. So if I think about negative infinity on my number line, that's on the left-hand side. My arrow is going to point in that direction, and I take everything up till 4 with a closed circle because of the bracket. We can figure out the second half the same way. We start with 5, then we go off to positive infinity. So we have an open circle because of the parenthesis and an arrow going off to the right. Pause the video and see if you can do the last 2. Alright, if we look at our first one, this looks just like the first interval from our union up above. So we're going from negative infinity to negative 9, and we have a closed circle because of the bracket. For this one, we're going from negative 7 to 6. Negative 7 gets a closed circle because of the bracket, and 6 gets a parenthesis, or an open circle, because of the parenthesis.